Welcome to our lecture online, and here's another example of how to find the center mass of an object. In this case, it's a very irregularly shaped object. Doesn't look like any particular shape that I can think of, but what if you have to find the center mass of this? How do you go about doing that? Well, the best thing to do is, first of all, place it somewhere at a coordinate system. So we're going to make this the y-axis right here, and make this the x-axis, which means that one corner of the object will be placed right at the origin. Okay, now at least we have a frame of reference. The next thing we're going to do is divide this into however many pieces we need to, so that we can come up with pieces where it's easy to find the center mass of each individual piece, and that's typically rectangles or squares or something like that. So if we cut it over here and cut this over there, we now have three different pieces: piece number 1, piece number 2, and piece number 3. So what we're going to do now is we're going to find the center mass of each and then add them together according to our equation. Center mass in the x direction is equal to the sum of I equals 1 to 3, because there's three pieces, of the mass of each piece times the center of mass of each piece in the x direction, all divided by the sum of all the masses. Again, from I equals 1 to 3, because in this case there are three pieces to this object. Now, they didn't give us the mass. They gave us the dimensions, and let's say that the dimensions are in meters. And in meters. So this is all in terms of meters. So instead of using the masses, we can use the areas, because assume that these are, like, let's say, thin plates, so that the mass of each plate is proportional to the area, the surface area of each plate. So we can actually find the exact same thing by saying this is equal to the sum of all the areas times the center mass of each area divided by the sum of all the areas from I equals 1 to 3, from I equals 1 to 3. So we get the exact same result that instead of using their masses, we use their areas, as long as the areas are proportional to their masses. All right, so knowing that, we're going to go ahead and start. So we take the area of the first portion, for first piece, and it's 5 times 3, which is 15 square meters. So that's 15, times the center of mass in the x direction of that piece. Since it's 3 units wide or 3 meters wide, the center mass in the x direction would be at the halfway point, so that means it would be 1.5 meters to the right of the origin, so we write 1.5. So this is the area times the x coordinate of the center mass, plus. Take the second piece, take the area. So if this is 3 and this is 1, let's see here, that's 3, then this must be 2 units long, or 2 meters long, like that. So 2 times 5 is 10, times the center mass in the x direction of that piece, which would be right over there. So this would be 3 units long. Since this is 5, from there to there would be 2.5 units long. This is 2.5. So 3 plus 2.5 is 5.5 meters to the right, 5.5. And then finally the last piece, that piece is 2 wide and 3 high. That's 2 times 3, which is 6 square meters in size. And the center mass of that area is right there. And so it would be 3 plus 5 is 8. And halfway between 8 and 10 would be 9. So that would be 9 meters to the right of the origin. So what we've done here is we've multiplied the area, not the mass, but the area of each portion of that object times the x coordinate of the center mass of each piece. And we divide that by the sum of all the masses. So in this case, that's equal to 15 plus 10 plus 6. I did say the sum of all the masses, but really what we're doing here is adding the sum of all their areas. So what is this equal to? 15 times that would be 22.5 plus 55 plus 54, all divided by 15 plus 10, that's 25, that's 31. So that would be 109. Added to that, that would be 131.5 divided by 31, which is, and for that I need my calculator if I can find it. It's here somewhere. All right. So let's see, that's 109 plus 22.5, just making sure, divided by 31 equals, and it's 4.24 meters. which means that from the origin to the right, a distance of 4.24 meters, so that's 3, that's 4, 4.24, somewhere along this line, I will find the center mass. Now we need to find the y-coordinate of the center mass to find the exact location for this object. So we'll do the same thing again, like we did for the x direction, we'll now do for the y direction. So the center mass in the y direction is equal to the sum of all the areas of each piece times the center mass of the area of each piece. And so for I equals 1 to 3, because there's 3 of them, divided by the sum of all their areas from I equals 1 to 3. So this simply means we're going to sum the product of the area of each one of these times the center mass in the y direction for each one of them. So this is equal to, again, the area is the same, it's 15, right? It would be 3 times 5, that's an area of 15 square meters, times the y-coordinate of the center mass here would be halfway from there to there. That would be halfway of 5. That would be 2.5 meters. Plus the area would be 2 times 5, which is 10, times the location of center mass, which would be halfway from here to there. Since this is 2, halfway would be 1, plus the area of this one, which is 6, times the location of center mass. It would be halfway from 0 to 3, which would be 1.5. And divide the whole thing by the sum of all their masses, which we already know. In this case, the sum of all their areas, which we already know to be 31. Simplifying this, that would be 25, and that would be 37.5, plus 10, plus 9, all divided by 31. And so adding that together, that's 47.5, 56.5 divided by 31. And 56.5 divided by 31 equals, and that's 1.82. That's in the y direction. So not quite up to this point, so a little bit less than that. So right around here. And where those 2 points meet, right there, that's the center mass. And the center mass has the x-coordinate of, we found 4.24. And that's, of course, in meters. And the y-coordinate is 1.82. And that's, of course, also in meters. And so that's how you find the center mass of an irregularly shaped object. If you can cut it up into small little chunks, where each chunk you can easily find the center of mass of that particular piece by itself. All right, there you go. Next example will be one where you cannot go do it like this. You will actually have to use integration to find the center of mass of an object. So if you'd like to see how that's done, stay tuned for the next one.